Welcome back. For some reason my other videos cut off, so this is going to be take 2. Alright, this is going to be session 1B. Okay, so I believe where this video cut off was when we were talking about problem number 4, right here. Okay, so in this session we're going to do problems 4, 5, and 6. So here it says that we have two circles that have a common chord. Okay, so I know that these two circles intersect. Okay. And if these two circles intersect, there's really only one spot where they can actually have a common chord. So a chord that is a part of both circles, and that would be this chord right here. Now, it tells us that this chord is 26 centimeters long. Okay, so we'll get there in a second. And it tells us that the centers of the circles, let's say that this is the center of the one circle right here, and this would be the center of the other circles, or the other circle. It tells us that the center is 25 centimeters apart. Okay, so I know that this is going to be 25. Now, since we're connecting the center of the circles, okay, that means that the center here is going to bisect this chord right here. Okay, so that means that this chord is 26 centimeters long. Each part of that chord is going to be 13. Okay, and what did we talk about yesterday with our theorems? I know that if a radius of a circle bisects a chord, then it is also perpendicular to it. So I know that I have right angles all around. Now let's finish reading the question here. It says the radius of one circle is 20 centimeters. So let's make the radius of this circle 20. Find the radius of the other circle. So it wants us to find x. Okay. Now, one of the biggest parts of this problem is what I mentioned earlier, is that seeing that since I'm connecting the centers, this chord has to be bisected. So this would be 13 and that would be 13. Okay, now what I need to do is I need to use the Pythagorean theorem here to find this distance from here to here. Okay, because what that'll allow me to do is then find this distance, and I can use the Pythagorean theorem to find x. Now, if you didn't follow my explanation there, let's try this again. What I'm going to do is I want to find, we'll call this y. I've already used x, so we're going to call this y. So I'm going to use the Pythagorean theorem to find y, which is the distance from the middle of the chord to this side. So I'm going to say that y squared plus 13 squared is equal to 20 squared. And now, if I go ahead and solve for y, I should get y is equal to about 15.2. Okay, so this distance right here, which I'm about to color in blue, that is 15.2. Okay, now one mistake, one common error is thinking that because the common chord is bisected, that the distance between the centers is bisected. That is not the case. Just because the distance between the centers is 25, that doesn't mean this is 12.5 and this is 12.5 like we just showed. That means that y here, we use the Pythagorean theorem to show that y is actually 15.2, okay? Which means that the distance from the center, from the middle of the chord to my center of the second circle is going to be 25 minus 15.2, which gives me about 9.8. Okay. So I know that this distance here is 9.8. What that allows me to do now is use the Pythagorean theorem to find the other radius, because I have a right angle there. So I can go ahead and say that 13 squared plus 9.8 squared is equal to x squared. And now I can go ahead and solve for x. So if I do this, we should get, anybody got it? Yeah, Miles? Yo, you're right. Nice job. We got x is equal to 16.28. Very good. All right, nice job. Any questions? All right, if not, we are going to move on to problem number 5 here, okay? This is probably, I would say this is the longest of all the problems, okay? It's kind of a tricky one, but let's go ahead and set this up. It says find the radius of a circle. Okay, so again we have a circle there. I'm going to go ahead and draw that. And it wants me to find the radius of a circle in which a 40 centimeter chord is 5 centimeters closer to the center than a 34 centimeter chord. Okay, so let's make this our center. Okay, let's make this our 40 centimeter chord, and then we will make this our 34 centimeter chord. Okay, so here's what I'm going to do. I'm going to take this and I'm going to draw this radius. Okay, I'm going to draw a radius that's perpendicular to these chords. So we know the theorem that we talked about earlier, that if a radius is perpendicular to a chord, then it bisects the chord. So that makes this distance 20 and 20, because the entire chord is 40, and it makes each of these 17, because the entire chord is 34. So now what we're going to do is, what does it want us to find? It wants us to find the radius. Okay, so I'm going to go ahead and draw in our radius here. Okay, notice I'm drawing it so I can get a right angle. Okay, because since I drew the perpendicular chords, I have perpendicular lines there, or perpendicular right angles there. So I'm going to call that R. Now there's one piece of information we haven't used yet. It says the 40 centimeter chord is 5 centimeters closer to the center than the 34 centimeter chord. So that means that if this chord is 5 centimeters closer to the center, we don't know the length of this chord, so we'll call it X. That means that this part is 5 centimeters further away. So I know that this has to be, the distance between the red chord and the blue chord there has to be 5. So now I can set up a few equations. One of them is I can use this red triangle up here, and I can use the Pythagorean theorem and say x squared plus 20 squared is going to equal r squared. That's the first thing. Now, this next one is a little bit trickier. Okay, I'm going to go ahead and draw another radius, you'll see here in a dotted blue line, okay, to this point. Right, and again, since we have right angles here, I can come up with another equation. If I look at this triangle right here, follow my cursor, I can come up with the equation that x plus 5 squared, which is the distance of this line right here, x plus 5. So I have x plus 5 squared plus 17 squared is equal to, again, this is a radius, so this is, you could also call that r, is equal to r squared. And now I can go ahead and solve. So this x plus 5 squared, remember how we do that? We have to FOIL that. So that's going to give me x squared plus 10x plus 25. Okay. And then 17 squared is 289, and that's equal to r squared. Alright, so now we have two equations here. We have this red equation and this blue equation. So we're going to do a little bit of substitution. Alright, I'm going to take this. I know x squared plus 20 squared is equal to r squared, so I'm going to take that and go ahead and plug it in or substitute it in for r squared. Since they're equal, I can do that. So now I have x squared plus 10x plus 25 plus 289 equals x squared plus 20 squared. I'm running out of room. Okay. So if I go ahead and simplify this, 25 plus 289, I'm going to go write this over here now. I have x squared plus 10x plus 314 equals x squared plus 400. Alright, now, I know what you're probably all thinking. You're probably all thinking, this is sweet because now the x squareds are going to cancel out. Yeah, you're right. You're absolutely right. My x squareds cancel out, so now I have 10x plus 314 is equal to 400. And we can go ahead and solve for x. So if I subtract 314 from both sides, I get 10x is equal to 86. And that's going to tell us that x is equal to 8.6. Alright. Now, that'd be nice if the problem said solve for x, but it doesn't. It says find the radius. So if I want to find the radius, I have to take this 8.6 and plug it back in for x and solve for r. So that's going to give me 8.6 squared plus, I'm going to simplify 20 squared right now to be 400 equals r squared. And now I can go ahead and solve for r. So when we do that, we get r is equal to about 21.77. Okay. All right. Any questions on that one? It's a tough problem. Okay, if you have any questions, let me know. Let me know tomorrow. Okay. Last one we're going to do for right now is number 6 here. Okay, again, that should say circle P. It says given circle P and PQ is congruent to PR. So let's go ahead and mark those congruent. And then it tells us that AB is equal to 6x plus 14 and CD is equal to 4 minus 4x. Okay? Now for this one we're going to use a very specific theorem. Okay? If you notice here, these PQ and PR being congruent to each other, that tells us that AB and that chord AB and chord CD are equidistant from the center. Okay? So let's look and see if we can find a theorem that matches it. Alright? How about this one right here? It says if two chords of a circle are congruent, then they are equidistant from the center. Okay? That's the opposite of this theorem right up here. Okay, or the converse of this theorem up here, which says if two chords of a circle are equidistant, which we have in our problem, okay, then the two chords are congruent, or then they are congruent. So I'll go down here. I know AB and CD are equidistant from PR, or is equidistant from the center, because PR and PQ are congruent, which means that chord AB and chord CD are congruent. So I can go ahead and set up the equation. 6x plus 14 is equal to 4 minus 4x. And now I can go ahead and solve. So if we take a second, go ahead and solve. Add 4x to both sides and subtract 14. We're going to get 10x is equal to negative 10. What? There we go. 10x is equal to negative 10. Which means x is equal to negative 1. So I know x is equal to negative 1 and I want to find AB. I can take that negative 1, plug it in for x there. So I have 6 times negative 1 plus 14 is going to give me AB. And so that's going to tell me that AB is equal to 8. Alright. That's all for session 1B. Okay, nice job today, and let me know if you guys have any questions.